Mason company, headquartered in Charlotte, North Carolina. I work out of the Charleston, South Carolina office doing field work, sales, and support for our customers. Cavitation can occur in process conditions where the fluid is moving quickly and it goes through a restriction. As it goes through the restriction, the liquid undergoes a change in velocity and therefore also a reduction in pressure. And if that pressure goes below the vapor pressure of the liquid will turn into a vapor and we get cavitation. So as we look at cavitation in control valves, we'll see that there's quite a bit of difference between a globe style or linear style motion valve versus a rotary valve. And in a globe style valve, the flow is moving and takes a 90-degree turn to enter into the valve, comes through a treacherous path, goes through the port, and then takes another 90-degree turn out of that. So there's a lot of energy dissipated, a lot of pressure that's lost and permanently lost through that device. So it is considered a low recovery valve. So where we get the contrast to that is, rotary valves like a V-ball or a butterfly valve. Whereas in a rotary valve, you see that the flow moves through the valve and the restriction in there doesn't make it go through a tortuous path. So there is a much higher recovery between the minimum pressure as it goes through the vena contracta and the recovered pressure. So it's a high recovery valve and thus has a tendency for greater cavitation issues. A lot of times we see those in the pulp and paper market or in water, cooling towers, other flow like that, where we see such a high pressure drop. We use a rotary valve because it's economical, and then we find that cavitation exists. There's only a few things we can do about cavitation. Part of it's the design and how we select a valve for it, whether it's going to cavitate or not. There's a cost trade-off because as you get in larger sizes, those globe valves get to be quite a bit more expensive. And then the rotary valves become so much more cost-effective that finding another way to handle the cavitation and potential damage from it is the right way to go. There's some designs in rotary valves that help alleviate cavitation within the limits of what their capability are. There's also materials of construction that we use for cavitating service, and also a lot of geometry, as that when we see and understand that there's going to be cavitation and potentially damage, we create a geometry where that damage doesn't occur inside the valve or to the adjacent pipeline, and let the energy dissipate amongst itself as it moves down the flow stream. Another interesting kind of way to handle cavitation is through a concept called aspiration. It's where we're going to allow air to be brought in from the outside the pipeline through a check valve and introduced into the flow geometry. In that case, we don't stop the cavitation at all. We just provide a cushioning impact with the air that goes with the vapor bubbles and prevents the damage from occurring to the pipeline. Aspiration's been used for a long time. There's some sizing, some technique to putting that into play. More details are available, with your account service people, but we've got some solutions to do that. Look forward to seeing if there's something that I can help you with, someone at RE Mace can help you with. We've got some experience in doing these kind of applications and look forward to those opportunities to work with you.